Well, that was a short video, wasn't it, Shelby? Super short, right? Okay, so let's get down to business right here. And this is the fourth and truly final um, uh, lecture for AP Chemistry. Okay, so what we're going to look at right now, we finished up with these concentration cells. The little ox is going to do oxidation, so therefore the electrons come out, the one with the lower concentration. Hopefully you remember that. And then there's a nice summary again of concentration cells. And this is our very last chemical equation from your purple sheet. I equals Q over T. All right, that being the current, which is what we're measuring essentially when we're looking for how strong or how good a battery is, and then charge in coulombs divided by time. We'll be using Faraday's constant. I think this is different than the one on the purple sheet. I'm not positive. I don't have one to check right now, but we'll go ahead and use this 96485. I think the purple sheet maybe has 96500 plus or minus, 1,000, plus or minus 100 coulombs per mole. So at any rate, we can use this equation if need be to relate time and charge. So what this gives us is just some kind of unique little factor label method problems. So how much charge passes through a certain wire with a current of 0.987 amps, just about 1 amp, over a course of 12.3 minutes. So if we're going to use factor label method and trust our gut here, we need to decide if we're going to start with this number or that number. And here's the thing, an amp can actually be a conversion. So we won't start with that. We'll start with the 12.3 minutes. All right? And then, of course, we're going to need to convert that into seconds. So you do that real quick. And you can use the parentheses that I normally do as well there. And instead of saying amp here, you can say this many coulombs per second. Right, Shelby?
Yeah.
Yeah, you better believe it. And that gives you 728 coulombs when you crunch the math on that. And then you want to figure out the moles. Well, that's the Faraday's constant. Just use your purple sheet to look it up, but we'll use this number just to stay consistent with the slides here. And you crunch those numbers, and you get a small portion of a mole of electrons. So you can actually talk, you're counting the number of electrons. In the lab that we did where we processed this, and we figured out Faraday's constant, and we proved that there's 6.02 times 10 to the 23rd electrons in a mole. So that was kind of cool. I'm disappointed you didn't get to do that one. So anyway, an application of electrolysis would be to have like a copper solution, and you plug it in, stick a battery on it, and you can copper plate something. All right, and you could see, many of the metals that you have been processed this way, just electronically. Put the metal just on the surface. It's a big money saver. Instead of having pure gold, you can plate it onto the surface. How long would it take to plate out 3.5 grams of silver from a solution containing silver ions with this amp of current? So again, we're going to start with 3.56 grams because that's the singular unit. You're going to convert grams into mole. That's your gut tells you to do that, right? And then this one's a little bit tricky. You have to say, well, there's 1 mole of electrons lost for every ion that's formed. So that's where you get the 1 mole of silver to 1 mole of electrons, because each atom gives off 1 electron. If it was a +2 charge, then that would be 2 electrons on the top there. +3 charge, that would be 3 electrons on the top. And then we use our good old constant value there to get 96,500 coulombs per mole. And then lastly, you need to convert that into the time, and you do that by using the amps as a conversion, kind of inverted. And they just add one more thing to go to minutes, because a little more reasonable number. Okay? They didn't ask for minutes in the problem, so certainly you could have stopped it at seconds right there. But that gives you, because of the amp reading, 2 sig figs, because that's what limits you to the 2 sig figs there. Okay? So, example number 2. If you have 2 Faradays of electric charge pass through a silver nitrate solution, what mass of silver will be plated out? So if you were somehow able to monitor or count the Faradays of electric charge that you're using, you can figure out how much silver ends up on the surface of something. So what we have to do first is double Faraday's constant and say that there would be 2 times 96,485. And that basically you could just put the 2 right here, because your first conversion you want to get to electrons. So if you wanted to, you could just put 2, but then you don't really have the factor label to work with. So you put a 2 out in front there and just say there's 2 moles of electrons. That would be reasonable to do in your head. And then, of course, this statement, because we know it's a +1 charge, and then you can go from moles to grams and figure out that you end up with that many grams. And if you look here, I got 5 sig figs. I've got 5 sig figs and 5 in that number as well. I could see a justification for rounding that to 220 grams, but certainly this is one of those that would have some flexibility with the significant figures. Okay, so these are all quantitative problems dealing with electrolysis. Okay, so now we've got an unknown metal, and they give you the molar mass of it in grams per mole. So you could probably use your periodic table to guess what metal that was, but that's not what the question is. The question is, what is the charge of the unknown cation? And as you know, many, especially transition metals, they have multiple charges that they could be. So we're going to have to work this problem out either way. All right? So the first thing that you want to do is take the 1.4 grams of the unknown metal, and it's only unknown in terms of what the charge is. So we do know, for instance, that it's 150 grams per mole. That's easy to just do mass spec and figure that out. So we've got 9.33 times 10 to the minus third moles of this unknown charge on this metal. So now we got something we can work with, because we can find the moles of electrons that are actually transferred. All right, and we do that by starting with the time, 60 minutes, convert that into seconds, and then use the current to say there's this many, the 0.500 coulombs per second, and then use Faraday's constant again, and then you have, there's 1.87 times 10 to the minus 2 moles of electrons. Okay? So that is how many electrons were actually transferred in the process. But let's find the moles of electrons per moles of metal, okay? Because when we went back here, we said we had this many moles of unknown metal. If you have 1.40 grams, that's an easy, just a conversion right there. And then, well, hey, Shelby, say goodbye to everyone.
Bye.
All right. Is it time for you to go to bed now?
Yeah.
Okay. All right. So we're going to find the moles per mole of metal. So you're basically just setting up the moles of electron, which is right up there, that actually passed through there. And this is, that's my wife, Julie. And there's my dog, Ginger, over there. Hey, Ginger. You can probably hear her breathing, if nothing else. Ginger. All right. So she walks like 20 feet and gets winded, kind of like her old man. All right. So so we're going to divide this out. This might be one of those that would be like a multiple choice question, and you would have to kind of do this in your head. So basically, if you think of this, if you look at this is to the minus second, so you could think of this to make the math a little simpler. You just go, this could be 18 divided by 9. If you were to look at how you're adding this up, because this is a smaller number here by 1 decimal point. So that's 1.8 times 10 to the second divided by 9.33 times 10 to the minus third. Just go 18 divided by 9. That works out, because you kind of make this one to the minus third. That would be 18. And then you can just say, well, that's what they get as a plus 2 charge. Now, if this was a free response, you're going to have the old calculator, and you just punch those numbers in there. But you kind of learn, some of those little tricks to just do that in your head and just say this number is twice as big as that number. So it's a 2 plus cation. All right. So, ladies and gentlemen, I'm hitting the arrow, and there ain't no more AP Chemistry to learn. You are as smart as you can get, according to the AP curriculum. Problem is, you probably forgot some of this stuff, or you probably will forget some of this stuff. So review like crazy, work real hard, beat up that review manual, and just get yourself a really, really good review. Remember, the classroom's going to stay up. I might post some stuff, some helpful things throughout between now and the testing date. But I just want to say, in all sincerity, that you guys have been absolutely tremendous through this, what has been the most challenging year of my teaching career. And I think back, some of you started with me in 9th grade, which was one of my best years of teaching, and then even had me for chemistry and GOB, and I just think that you guys are really the best. I love you guys, and I want to thank you for making this job great, even through tough times. You guys take care.